Okay, so we're on 8.2, alcohol absorption and metabolism. So to start off, alcohol is not digested. Okay, so if I ask you questions about that, make sure you tell me alcohol is not digested. So unlike proteins, carbohydrates, and lipids, where we talked about digestion happening in different organs throughout the GI tract, alcohol is not digested. Instead, it is absorbed directly through the stomach, about 20%, and the intestine, the small intestine, about 80%. Okay? Absorption in these organs can be slowed by the presence of food. Okay, so if you eat a meal while you're drinking alcohol, alcohol absorption is slower, and therefore blood alcohol levels go up slower. If you drink alcohol on an empty stomach, that's not a good thing because alcohol gets absorbed much faster. Okay. After alcohol is absorbed, either in the stomach or in the small intestine, it's going to be transported to the liver, just like pretty much everything else, right? And in the liver, the alcohol will be metabolized. So it doesn't get digested, but it does get metabolized. It gets metabolized at a rate of approximately 1/2 to 1 alcohol drink equivalent per hour, somewhere between 10 and 14 grams of alcohol per hour. And that number kind of depends on the individual. Most places where you read about this, it'll say 1 drink equivalent per hour, which is about 14 grams. But again, there is kind of a range. Any alcohol that is consumed that doesn't get metabolized, right away, we would consider that to be excess. And it's going to circulate in the blood until the liver can get to it. Okay, until the liver can actually metabolize it. A small amount of alcohol that is unmetabolized will be excreted in urine, breath, and in sweat. And we'll talk about the alcohol in breath. We're able to actually measure that using a breathalyzer, and we'll get to that in just a little bit. Okay, so alcohol is not digested. Instead, it is absorbed and metabolized in the liver. It will circulate in the bloodstream until the liver gets to it. And again, a very small amount will be excreted unmetabolized. Okay. So alcohol metabolism pathways. So to start, it's an absolute priority to metabolize alcohol as a fuel source. It cannot be stored in the body, and the goal of your liver is to convert ethanol, the alcohol, which is toxic, to a less toxic compound. Okay, and again, the liver is going to be the chief site for this process that again we call alcohol metabolism. So here is the primary route. So again, there's actually 3 different routes by which alcohol can be metabolized, but something like 90% of the alcohol that we consume will be metabolized via this primary route. So individuals who drink low to moderate levels of alcohol, again, this will be the primary route. It is called the alcohol dehydrogenase, or ADH pathway. There are 2 key enzymes involved in this pathway. The first one is called alcohol dehydrogenase, and the second one is called aldehyde dehydrogenase. Okay? Alcohol dehydrogenase is going to take ethanol, and it's going to convert it to an intermediate molecule called acetaldehyde. And then the aldehyde dehydrogenase will take the acetaldehyde and convert it into acetyl-CoA. Acetyl-CoA, the end product, is then used for fatty acid synthesis. So, when you drink alcohol, it turns to fat. That's the moral of that story. This intermediate molecule, this acetaldehyde, is actually more toxic than ethanol. So it's really important that our bodies fully break down ethanol. If acetaldehyde lingers, so there are individuals who either have high levels of alcohol dehydrogenase or maybe low levels of aldehyde dehydrogenase, and that means that acetaldehyde, that intermediate molecule, hangs out a little bit longer. It does a lot of damage. Again, more toxic than ethanol. It can cause DNA damage. High levels are linked to cancer. We'll come back to that in just a minute. Okay, So this is what the pathway looks like. So here is your alcohol that you've ingested, right? It's traveled to the liver, and now the liver is going to metabolize it and break it down. Okay, so alcohol will be converted into acetaldehyde. This is the intermediate molecule. The enzyme that does this, again, is called alcohol dehydrogenase. And then a second enzyme, aldehyde dehydrogenase, will convert acetaldehyde into acetyl-CoA. And acetyl-CoA is then going to be used to produce fatty acids. Okay? And some of the byproducts are CO2 and water. Okay, so there's the first pathway, the alcohol dehydrogenase pathway. Again, low to moderate levels of drinking, that pathway is going to be the one that's used. During moderate to excessive alcohol intake, the ADH, the alcohol dehydrogenase pathway, is working, but it can't keep up with the levels of alcohol that are coming to the liver. And so the liver is going to activate a secondary pathway, which is called microsomal ethanol oxidizing system, or MEOS, to help. MEOS is going to produce the same intermediate, so it still produces that acetaldehyde, which is not good news, but it uses energy. Okay, so energy has to be put in for that process to run. Individuals who are chronically take in excessive amounts of alcohol, so if they have alcohol use disorder, or you can say if they're alcoholics, what happens is MEOS is more active, right? It gets turned on more of the time. And what happens is there is more efficient metabolism, right? So now, the ADH pathway's on, the MEOS pathway's on, and your liver knows what it's doing. And what happens is you build up a greater tolerance. So it takes more alcohol to produce the same effects in individuals who are chronic drinkers, chronically abuse alcohol. Okay, here's another problem. This MEOS pathway is not just used to metabolize alcohol when the ADH pathway is not keeping up, but this pathway is also used to metabolize drugs and other foreign substances. So remember, your liver is the detoxifying organ. That doesn't just mean alcohol, it means toxins like drugs and other toxins that can be found in other foreign substances. So when the MEOS pathway is activated when individuals consume excess alcohol, the liver's capacity to do its other job, metabolize drugs, is decreased. And so this is going to slow down drug metabolism in the liver. And that causes drugs to stay in the body longer, increasing the risk of toxicity from those drugs, increasing the risk of overdose. Okay, so alcohol and drugs don't mix well. Okay, so here's the pathways. And again, I said that there was 3. I'll talk about the last one just briefly on this slide. So again, the ADH pathway is going to be the predominant pathway. Mostly happens in the liver, but it can start in the stomach. Again, low to moderate intake of alcohol, this pathway will predominate. It will be the only one that's activated. It's going to metabolize about 90% of alcohol. Again, when intake becomes higher, so moderate to excessive intake, the ADH pathway gets overwhelmed, and so the MEOS pathway has to step in. Again, this is going to happen in the liver and hepatocytes. And again, this is going to turn on when there's increasing alcohol intake. The last pathway down here, the catalase pathway, this is very minor. Again, this will happen in liver and other cells. It only gets turned on when there's moderate to excessive intake as well. Okay. Okay. Factors affecting alcohol metabolism. The ability to produce appropriate levels of both enzymes in the alcohol dehydrogenase pathway is going to be key to breaking down alcohol. Okay. There are certain individuals, because of genetics, that are going to not have appropriate levels of these enzymes. For example, Individuals of Asian descent, and this is actually nuanced. This is actually not unique to Asian people of Asian descent. There are other ethnicities as well. But again, the most well-known, the most documented are individuals of Asian descent. These individuals, some, if they have the genetics, they have normal to high activity of the first enzyme, which again is called alcohol dehydrogenase. This is the one that converts ethanol to acetaldehyde. But then they have low activity levels of the second enzyme, aldehyde dehydrogenase. So they're unable to quickly convert acetaldehyde to acetyl-CoA. And so they end up with the toxic effects of acetaldehyde. So what do those include? Flushing. So, flushing, getting rosy cheeks, appearing red. Dizziness, nausea, headaches, rapid heartbeat. So that's called tachycardia. Rapid breathing. They feel like they're hyperventilating. So even low levels of alcohol can do this to some people. And again, this enzyme, the intermediate acetaldehyde, the longer it's around, the more damage, it's doing. And so individuals who have this issue, they're at a greater risk for the toxic effects of acetaldehyde, which again includes cancer. Okay, and there's certain forms of cancer that alcohol is really linked to. Okay, what other factors? Biological sex. So women produce less alcohol dehydrogenase in the cells that line their stomachs. So remember, the ADH pathway starts in the stomach, so a certain percentage will start there. And so again, women produce less of this enzyme in their stomach specifically, and so they absorb 30 to 35% more unmetabolized alcohol from their stomach directly into their bloodstream. And so the liver has more unmetabolized alcohol to deal with than the equivalent of in men. Okay. Secondly, women are generally smaller and generally have more body fat and, more importantly, less total water. And so alcohol becomes more concentrated in the blood and in body tissues. It's not diluted. There's not high levels of water. And so because of these two things, women become intoxicated on less alcohol than a man, even of similar size. And then the last factor affecting alcohol metabolism is age. And so young individuals, so teenagers, underage drinkers, for a couple of reasons, one of them being that the alcohol dehydrogenase pathway is not fully developed yet. And so teens, again, are going to feel intoxication faster, and they're not going to handle alcohol as well, as an adult. Older adults also metabolize slower. And so again, same thing here, actually, same thing that we find in women. Older adults tend to have a different body composition, again, less water. And so again, they have greater effects from alcohol. Okay, so alcohol stays in their, blood longer. The liver doesn't metabolize it as fast. Okay. Rate of alcohol metabolism. So again, there's lots of factors here. Age, ethnicity, gender. But overall, when alcohol consumption exceeds the liver's metabolic capacity, so when the liver, can't break down alcohol as fast as it's coming in, what will happen is blood alcohol levels are going to rise. Okay, and that's when you get symptoms of alcohol intoxication, being drunk. Okay, and this is because your brain and your nervous system are exposed to alcohol, unmetabolized alcohol. So when your blood alcohol levels rise, we can measure this. So this is the blood alcohol concentration, or BAC. This is the we can measure this through a breathalyzer. this is going to be the amount of alcohol that's excreted through the lungs. It is a direct measurement of alcohol being exhaled, but it is directly correlated to the amount of alcohol in the blood. Okay, so blood alcohol concentration, we can measure it using a breathalyzer. Again, the alcohol content of exhaled air is measured, and that content is equivalent to the blood content. Okay, they're going to be equal. The breathalyzer, so the legal limit for driving is going to be 0.08%. Okay, and I've got this nice table here. Hopefully you can see this. So we've got, the effect on women, the effect on men, and then the number of drinks. We've also got body weight in pounds here. Okay, so you can kind of figure out where you fall. But you'll notice, in yellow, driving skills are significantly affected. And the cutoff there doesn't matter if you're female or male or what weight you are, it's 0.07. If you get to 0.08, that's legal intoxication. Okay. Whether you're a 120-pound woman, 0.08 is legal intoxication. Or if you are a 180-pound woman, it's still 0.08. The difference here is the amount of drinks that it takes to get you to that level. Okay. So, most individuals with one drink, their driving skills are definitely affected, so you shouldn't drive, right? But you're not legally intoxicated. Okay, the only safe driving is 0 drinks. Anything above 0 drinks is you really shouldn't get behind the wheel. But some individuals can have 2 drinks and still be under the legal intoxication levels. Okay, so men from 120 to 240 or above, they're going to be okay. But a man that's below 120, they're going to be risking, if they've got pulled over, being legally intoxicated. And the same thing for women. If you're 140 pounds or over, you're probably okay with 2 drinks. You probably still shouldn't drive, but you're not going to get, in trouble. But again, if you're under 140, so again, we hit that 0.08. So 0.08% blood alcohol content, BAC, is the legal limit. You'll also notice that we've got here down in the red, possible death. Okay, so individuals having, 6 or more drinks, depending on your weight and gender, there is a risk of death. Okay, and if we go farther down, you'll see that the risk of death, you're going to see the red for everybody. Okay, there is a limit to how much alcohol your body can handle. Okay, this is the same kind of a chart here. So again, this is blood alcohol content in percents. Okay, and you can see possible behaviors and feelings, and then impairments. So if you have a blood alcohol level between 0.01 and 0.06, it's actually still legal to drive here. You might feel relaxed. You might feel kind of happy. Loss of inhibition, but you're also less alert. You might have slightly impaired judgment. Coming down here, 0.06 to 1, now you're in the legal limit for driving. You probably think you're functioning better than you are, which is why some people get behind the wheel. Relaxed, you might look intoxicated. You do have impairments, so depth perception, reaction time, balance, speech, vision, hearing, judgment, reason, memory, all of those decline. When you get over, okay, so 0.11 to 15 there, obviously intoxicated, mood swings, vomiting, it's starting to get dangerous. Okay, obviously you have lots of impairments. And as we go down, so again, greater than 0.4, life-threatening. You risk alcohol poisoning, which we're going to get to in just a second. Okay, and just to come over here, when you start to get down to these, high levels here, 0.3 to 0.4 or above, lots of physiological functions are severely impaired. So what happens is your heart rate slows, your breathing slows, you start to become hypoglycemic, low blood sugar, you have loss of bladder control. Okay, so dangerous. Okay, even here, there is still this risk of passing out, nausea, vomiting, extremely drunk. Here, even if you don't have alcohol poisoning, if you're vomiting and you fall asleep, you may choke on your own vomit. So dangerous, very dangerous. Okay. And again, if you come back here, you can see how many drinks that is. Okay, so you can kind of check that out. It's dependent on gender and it's dependent on weight. Okay, so everyone's going to kind of be different on that chart. Okay, so high blood alcohol levels. So, high, above 0.16. This is really high down here over 0.4. Okay, so high blood alcohol levels can result in acute alcohol toxicity, which is also known as alcohol poisoning. Okay, that's going to require immediate medical attention. That is very, very dangerous. Risks, associated here are binge drinking. So again, for females, 4 or more drinks. For males, 5 or more drinks in a single occasion are going to increase the risk of alcohol. It definitely depends on the time span, right? So if you're having 4 drinks over a 4-hour period, depending on your weight, you're probably going to be okay. But if you have, 4 drinks in a half an hour and, they're shots that are at higher alcohol content, that's pretty dangerous. Okay. Oop, missed that one. Okay. So alcohol poisoning signs and symptoms. Confusion. Individuals will act like they're in a stupor. They're not sure what's going on. Vomiting. Low blood sugar, which is known as hypoglycemia. Severe dehydration. Seizures. Slow or irregular breathing. Slow, irregular heartbeat. Blue tinged or pale skin. Low body temperature, which is also known as hyperthermia. And loss of consciousness. These are all signs and symptoms of alcohol poisoning. Of course, if you're with somebody who has alcohol poisoning, you should call 911, okay? And you will be routed to, there will be emergency response. You can also call this number here, and you could be routed to your local poison control. That's if the person is conscious, okay? I would probably just call 911. Okay, so the next day after binge drinking, as long as the person doesn't die, right, from alcohol poisoning, many times people will wake up with a hangover. And so here are the causes of a hangover. So first off, you're suffering from acetaldehyde toxicity. So that's going to cause the headache, the nausea, the flushing, the sweating, the rapid heartbeat. If acetaldehyde builds up, hangover symptoms worsen. And this occurs, again, with heavy or rapid drinking. Dehydration and electrolyte balance. Alcohol causes increased urination. You're losing fluids. You're losing electrolytes. This is going to result in thirst, dizziness, weakness, dry mouth. Sleep disruption. So you're not going to enter the REM cycle. It's going to be very disrupted, and so that you'll have poor sleep quality, and that's going to cause fatigue, irritability, confusion, cognitive fog. You're not going to be able to think clearly. Hypoglycemia. So again, this is low blood sugar. What happens is alcohol metabolism rises, what's called NADH, which we're actually going to talk about in the next chapter. When NADH levels rise, that's going to inhibit gluconeogenesis. So you are not generating glucose. And so your blood glucose levels will drop. That's going to result in shakiness, mood changes, and again, it's going to add to fatigue. You will also have an immune and inflammatory response because of the alcohol, because of this acetaldehyde. Again, those are toxic substances that your body will respond to. You will also have GI irritation. Alcohol causes an increase in stomach acid production. It also causes a decrease in gastric emptying. It's going to cause nausea, vomiting, stomach pain. All things that don't sound fun. So again, binge drinking will cause that. Okay, we're going to go on to 8.3 because it's kind of on the same lines as what we were just talking about. So again, we're talking about alcohol consumption. So I gave you a statistic earlier in the beginning of this chapter of 50% of adults in the U.S. So 70% of Americans, so this is U.S. and Canada, report consuming alcohol. Most do not drink excessively, so they might be low to moderate drinkers. Men report higher rates of intake than women. Data coming out from the COVID-19 pandemic showed that there was an increase in binge drinking from 25 to 33%. And it's thought that high levels of stress, fear, panic, and also boredom led to this increase in binge drinking. The largest drinking population in North America is white young college students, many of them not of legal age to drink. So that brings us to the impact of underage college drinking. And so just some stats, death, about 1,520 college students between the ages of 18 and 24 die each year from alcohol-related unintentional injuries, including motor vehicle accidents. Assault, about 696,000 students between the ages of 18 and 24 are assaulted each year by another student who has been drinking. 1 in 5 college women experience sexual assault, with the majority of assaults involving alcohol or other substances. About 25% of college students report academic consequences of their drinking, including missed classes, falling behind, doing poorly on exams or papers, and receiving lower grades overall. Higher amounts of drinking lead to more serious academic problems. 9% of college students meet the criteria for alcohol use disorder or alcoholics. They are alcoholics. Other consequences: suicide attempts, injury, unsafe sex, driving, vandalism, property damage, police involvement. Okay. So not great. So we'll stop this video here. We'll do 8.4 in the next video.